Welcome to the Omni-Cable Wire and Cable Education Series. Today we'll focus on conductors and stranding of wire and cable. By the end of this segment, you'll be well versed in conductors and stranding of wire and cable. There are many things to learn about the conductors and stranding of wire and cable, but shown here we have identified our main objectives. We will learn what a conductor is, which materials are used to construct a conductor, and what the difference is between solid versus stranded, along with which stranded constructions are available. We will also discuss conductor sizes, conductor coatings, and different alloys. This module will conclude with a short quiz to see how much you learn about conductors and stranding of wire and cable. What is an electrical conductor? A conductor is the part of a wire or cable through which electrical signals travel. Conductors allow the flow of electrical currents created by movable charged particles. A conductor's counterpart is an insulator, which does not allow for the easy flow of a current. Typically, electrical wire and cables consist of at least a conductor inside an insulator that contains the electrical current so that it moves in a particular direction. What are the materials used to construct conductors? Copper is the most commonly used conductor material in electric wires and cables. This is due to its conductivity and weight in relation to its production cost. It can be used bare with no other metals or dipped and combined with other metals. Aluminum is another common conductor material. It is not as effective as copper as an electrical conductor, but it is very lightweight and inexpensive in comparison. Silver has the highest conductivity. However, its high material and production costs make it a less popular option than copper. What are the main differences between solid and stranded conductors? Solid conductors are constructed of one single piece of metal. It is tougher than a stranded conductor, but rigid and less flexible than a stranded conductor. Solid conductors are more likely to break if subjected to frequent flexing than stranded conductors. Stranded conductors are made of multiple small strands, which group together to make up a single conductor. It is more flexible than a solid conductor, but less durable. Shown here are the four basic constructions of a stranded conductor. Bunch stranding is a collection of strands twisted together in the same direction without regard to the geometric arrangement. Concentric stranding consists of a central wire or core surrounded by one or more layers of helically laid wires. Each layer after the first has 6 more wires than the preceding layer. Except in compact stranding, each layer is usually applied in a direction opposite to that of the layer under it. Unilay stranding is the same as true concentric, except the lay length is the same in each layer. Normal direction of lay is left hand. Rope lay stranding is a concentrically stranded conductor, each of whose component strands are they themselves stranded. A rope stranded conductor is described by giving the number of groups laid together to form the rope along with the number of wires in each group. You can see here that the diameter of a conductor is affected by its construction. A solid conductor has the smallest diameter, and various types of stranding will increase its size. For example, here we can see that a compressed stranded conductor is about 10% larger than a solid conductor. This must be considered when a cable is being spec'd into a job. Both its flexibility and overall size are important. A conductor can be sized according to different standards and measurements. The system you will most commonly see uses the circular mill. A circular mill is an area of a circle with a diameter of 1 mil, where 1 mil equals 10,000th of an inch. This unit of measurement is used in determining the size of a cable's conductor. American wire gauge. It's the most commonly used system in the United States to describe the size of copper wire. That's the American wire gauge, or AWG. This standard largely relies on the circular mill area of a conductor. The larger the diameter of the cable, the smaller the gauge size used to describe it. So a 1 gauge cable has a larger diameter than a 10 gauge cable. Next, after 1 gauge cable, is size 0. From there, more zeros are added to the gauge size to express its diameter. So the next largest size would be 00. However, these cables are actually classified by how many zeros make up their gauge size using the term aught. For instance, size 0 is really 1 aught for 1 zero, and size 00 is really 2 aught for 2 zeros. This continues to size 4/0. This designation's MCM and KC mil are used for conductor sizes larger than 4/0. Shown is a comparison picture of 500 MCM versus 2/0 gauge. The NEC uses circular mils for these larger sizes also, but they are expressed in thousands of mils using the MCM or KC mil abbreviation. For example, 500,000 circular mils equals 500 MCM. As the MCM increases, the size of the conductor increases as well. Both solid and stranded conductors follow the same standards. As we have already seen, stranded conductors are slightly larger in terms of overall diameter because of the gaps in between individual strands. However, those gaps are not measured when calculating the actual gauge from the area of the conductor. So a 2-gauge solid cable may appear to have smaller diameter than a 2-gauge stranded cable, but they really are measured and classified as the same size. Conductors sometimes have metal coatings that help them perform in varying environments. Tin is a commonly used metal coating because of its effectiveness at reducing corrosion or oxidation and its ability to improve the solderability of cable. However, it can also increase the resistance of the wire. Silver is an effective coating for high temperature and frequency applications. It is effective in environments up to 200 degrees Celsius and can reduce attenuation or signal loss at high frequencies. Using a conductor coated with silver allows you to get some of its benefits while avoiding the high cost of a full silver conductor. Nickel is a good coating for applications with even more extreme temperatures. It's effective up to 450 degrees Celsius and also helps to reduce oxidation. However, it is not easily soldered. In addition to one metal being coated by another, metals can be combined with other elements to form alloys. There are many added benefits to using these elements on a conductor, such as strength, reduction of resistance, and the increased flex life of the cable. Alloys are commonly used in construction of thermocoupled cables. There are also different constructions of conductors, for example. An all-aluminum conductor is a type of conductor which has high corrosion resistance and is lightweight. It's used where supports are close together and space is limited, such as urban areas. An aluminum conductor steel reinforced conductor, or ACSR construction, is constructed the same way but has strands of steel within the conductor core, which gives it similar properties as an AAC conductor, with the added benefits of high tensile strength and the ability to span long distances without sacrificing ampacity. Next will be a quick quiz to review what you have learned. Please answer the following question slide to complete this module of the Omni Cable Wire and Cable Education Series. Thank you and good luck. True or false, insulation is the part of a wire or cable through which electrical signals travel. Please place in order the material with greatest conductivity to least conductivity. Drag object to correct order position from best to worst. True or false, solid conductor wire is typically used when a more flexible wire is needed. Please rearrange the following sizes from largest to smallest conductor. Drag the sized wire to the correct order sequence. A wire's gauge size consists of: match the type of conductor coating with its appropriate characteristic. Drag the conductor coating to its most appropriate characteristic. True or false, metal alloys have the ability to help improve strength, reduce resistance, and increase the flex life of a cable. This concludes the Conductors and Stranding Education Series module. Thank you for taking the time to learn about conductors and stranding of wire and cable.